Let's graph the absolute value function y equals the absolute value of x plus 2. Okay, so the graph of an absolute value function will consist of it'll look like a big V on the graph, and it'll consist of two lines joined at the vertex. The vertex is the point in the middle. To graph the function, we'll go ahead and start out by finding the vertex, and we do this by setting the expression inside the absolute value bars equal to 0, and then we go ahead and solve for x. So let's go ahead and find the vertex. What we do is we just take the expression inside x plus 2, and we're going to go ahead and set this to 0. Now this makes sense because wherever the value of is x that makes this expression 0, we'll have y equals 0, which means that's going to be the point on the x-axis, or when y is equal to 0. So let's go ahead and solve for x. We can subtract 2 from both sides. Those two terms will cancel, so we'll have x equals a minus 2. Now we're also going to need two other points to graph this absolute value equation. We're going to need a value larger than the vertex to see what's going on to the right of the vertex, and we're going to need a value smaller than the vertex to see what's going on the left side of the vertex. So let's go ahead and keep things simple. Let's use a couple of easy ones like x equals 0 and let's say x equals minus 4. Alright, so what we're going to do is we're going to go ahead and plug these 2 points into our original equation to find the other 2 points. So let's do this. We have y equals the absolute value of x plus 2, so let's plug in 0 for the first one. 0 plus 2. This gives us y equals the absolute value of 2, or just y equals 2. Alright, not a whole lot to it. Let's look at the next one. We have y equals the absolute value of negative 4, using our other point here. So we have plus 2, or other value, I should say. We have y equals the absolute value of minus 4, and a plus 2 is a minus 2, so we get the absolute value of another 2. All right, so we have 3 points now. Okay, we have this one, we have minus 2 and 0. Whenever x is minus 2, the absolute value equation of y equals 0. Our other point is 0, 2. Whenever we plug 0 in for x, we got y equals 2. And our third one is minus 4, 2. Whenever we plugged in minus 4 into our original equation, we got plus 2. All right, so now we have 3 points to graph, or plot, I should say, so we can graph the function. So let's go ahead and plot these points. We have minus 2 and 0, which is right here. We have 0 and 2. That occurs right there. And we have minus 4 and 2. So here's another one. All right, so we simply graph the function by drawing 2 straight lines connecting at the vertex. So we have one right here and one right here. And we have arrows on the end because these do go indefinitely. They're continuous. They go to infinity. The domain and the range are both the set of all real numbers. And that's the graph of the absolute value equation y equals the absolute value of x plus 2. It looks like the shape of a V, and the 2 lines join at this point called the vertex. All right, so not a whole lot to these. We just need to find a few points to plot, and then from there, we can simply draw our lines and connect them at the vertex. All right, let's go ahead and take a look at another one. Let's take a look at the absolute value equation. Y equals the absolute value of x minus 5. All right, we're going to approach this in the same manner. We're going to find the vertex by setting the expression inside the absolute value bars equal to 0, because we want to find out the value for x that makes the expression y, or the equation y equals 0. So let's go ahead and do that. So we have x minus 5 equals 0. Let's add 5 to both sides, solving for x. So we have x equals 5. So our vertex is 5, 0, which should be right about here. Okay, so let's find 2 more points, one on the left side of the vertex, one on the right side of the vertex. So we need a value greater than 5 and a value less than 5 to plug in our equation, and this will give us our 2 other points on the graph. So let's go ahead and pick x equals 6. That's a value greater than 5, and plug it into our original equation. So we have the absolute value of x, which is 6, minus 5. That'll give us y equals the absolute value of 1, which equals, or gives us y equals 1. So we have another point of 6, 1, and then we need a value smaller than 5. Let's go ahead and pick an easy one. Let's pick 0. 0 is a very easy number to deal with. So we have the absolute value of x minus 5. X in this case is 0, so minus 5. That gives us y equals the absolute value of minus 5. Whatever is inside the absolute value bars, we just turn it positive, so we have y equals 5. So now we have our third point of 0, 5. So let's go ahead and plot these. So we have our point 5, 0. We need a point 6, 1. That's right here. And the point 0, 5. So 0, 5 is right up here. Ooh, right there. Okay. Let's go ahead and connect these at the vertex. So we have a line going this way and a line going this way. All right. Again, it's in the general shape of a V. Both lines extend out to infinity because the domain and the range are both the set of all real numbers, and that's all there is to it. All right, so we're simply using what we know to find a few points to plot, and then we just connect them using our knowledge of an absolute value. Let's look at the next one. The next one we have is y equals the absolute value of 3x minus 9. All right, so we're going to approach this the same way. We need to find the vertex. Vertex is the most important point. It's actually, there's only one vertex for each absolute value equation. Well, there's an infinite set of points that we can actually find on the line. So we have 3x minus 9. We're going to set the expression inside the absolute value bars equal to 0. Let's go ahead and add 9 to both sides. Those two terms cancel, so we have 3x is equal to 9. Let's divide both sides by 3 to isolate our variable. So we have x equals 9 over 3 is 3. So we have the point 3, 0 as our vertex. So 3, 0 is right here. All right, let's find a couple more points. We need a value greater than 3 and less than 3. So let's go ahead and set x equal to 0. That's always an easy one for the value to the left of 3, and plug it into our original equation. So we have the absolute value of 3 times x, which is 0, minus 9. We have y equals 3 times 0 is 0, so we have the absolute value of minus 9, and the absolute value bars just turn that into a positive 9. So we have the point 0, 9. That's another point, and that occurs 6, 7, 8, 9 right here. Get a bigger point. And we need a value greater than 3. Let's don't get fancy with it. Let's go ahead and just pick x equals 4. So y equals the absolute value of 3 times x, which we're saying is 4, minus 9. That'll give us the absolute value of 3 times 4 is 12, minus 9. That'll give us y equals the absolute value of 3, which is just a positive 3. So we have the third point, 4 and 3. So we have 1, 2, 3, 4, 1, 2, 3. All right, so we have 3 points. Let's go ahead and connect them at the vertex. Both lines extend infinitely. Put some arrows on the end, and not a whole lot to it. So we're just getting a little more practice. We're getting comfortable with graphing absolute value equations. And we see that all absolute value equations are going to result in sort of a V-shaped function. All right, let's go ahead and do another one. Let's say we have the absolute value equation y equals the absolute value of 4x plus 1. All right, we're going to need to find the vertex, so let's set the expression inside the absolute value bars, 4x plus 1. Let's set it equal to 0 and solve for x. Subtract 1 from both sides. That'll give us 4x is equal to, minus 1. 4x is equal to minus 1. All right, we can divide both sides by 4. That'll isolate our variable. So we have x x is equal to minus 1/4. So we have the point minus 1/4 and 0 as our vertex. And we can plot that right here, right about there. This is kind of, we should have zoomed in a little bit for scale, but that's okay. All right, now we're going to need a point to the left of minus 1/4 and to the right of minus 1/4. Just because it's a fraction, we don't have to choose two more rational numbers. Let's just make life simpler for us. A point or a value less than minus 1/4 is just simply minus 1. So that's fairly easy to deal with. So we have 4 times x, which you're going to say is minus 1. We're looking for the point minus 1, and we want the y value, so let's go ahead and find that. That'll give us y equals the absolute value of 4 times a minus 1 is minus 4 plus 1, and I apologize, that's a 4, not a 9. And that'll give us minus 4 plus 1 is the absolute value of minus 3. Absolute value of minus 3 is simply 3, so we have the point minus 1, 3. And that will be right there. And we need a value of x greater than minus 1/4. And, well, a simple no-brainer is right at 0. So we have 0. We want the y value. So we want the value of y when x is 0 in our equation. So we have 4 times x, which is 0, plus 1. Y equals 4 times 0 is 0, so we have the absolute value of 1. That's just simply 1, so we have the point 0, 1. So we have 3 points. Let's go ahead and plot our third one, and that'll be right there. Kind of small for scale, but this will work anyways. Let's go ahead and we can extend it as long as we're going through our points. And there's our graph. All right, not a whole lot to it. Let's squeeze in one more. We got time for one more. Let's take a look at. Let's do y. Oh, excuse me. Y equals the absolute value of x over 5 plus 2. All right, so we want to find the vertex. So let's take the expression x over 5 plus 2 equals 0. Let's go ahead and subtract 2 from both sides. That'll give us x over 5 equals minus 2. And we can isolate x by multiplying both sides by 5. That'll cancel the denominator, so we have x on the left-hand side. 5 times a minus 2 is a minus 10. So we have the point minus 10 and 0. That's our vertex, which is way over here. All right, now we're going to need a value to the left of minus 10 and a value to the right of minus 10. All right. Now notice we want to make good decisions when we're picking values. Notice that we have a denominator of 5, so instead of picking just minus 11 and minus 9 or 0 or something like that, we notice that if we use a factor of 5, that will make life much easier for us. So let's go ahead and pick the value to the left of minus 10. Let's go ahead and pick minus 15. Now we're picking a much larger number, but this will make sense in a second when we plug it into our equation. So x equals minus 15 divided by 5 plus 2. Well, that's simply the absolute value of minus 15 divided by 5 is just minus 3, giving us a nice round whole number to work with. And we can simply say minus 3 plus 2 is the absolute value of minus 1, and that's just simply 1. All right, so we have the point minus 15 and 1. And let's go ahead and find one more. Let's use, instead of picking 0 out here, let's pick minus 5. That's another factor of 5, and that'll make life easier on us. So let's go ahead and use minus 5 and plug it in for x. So we have minus 5 for x divided by 5 plus 2. That'll just simply give us the absolute value of minus 1 plus 2, which is the absolute value of 1, and that's just 1. So we have minus 5 and 1 for this point. And let's go ahead and connect the dots. Those lines converge at the vertex. And not a whole lot to these. So we're just simply using our knowledge of what we know about, especially in the previous section about absolute value equations. We need 3 points. We need the vertex where the two lines will connect. And there's actually only one vertex, and that's when y is going to equal to 0. So we're going to set the expression inside. We can drop the value bars because 0 is neither positive nor negative, right? So we can drop that and just solve the expression inside the absolute value bars, what the value of x needs to be for this expression to be 0, because we want y equals 0. And that's going to give us our vertex, and then we simply plug in a value of x that's less than that particular number, and a value of x that's greater than that particular number, which gives us a point on both sides of the vertex. And as you see, it'll result in something that looks like a V. V's of different shapes and sizes, but a V nonetheless. So we'll do some more of these in the next section, and we'll actually be moving on after that to absolute value inequalities. So I'll see you soon.